Okay, today we are going to be talking about slope and the different forms of linear equations that we can write, some of them using slope. So to start off, to kind of get our definitions out of the way, we're going to start a linear equation is an equation whose graph in a coordinate plane is a line. So what makes a linear equation is that its graph is a line. So when we're talking about lines, we often talk about slope, and slope is the constant rate of change of a line. So we're talking about how slow or how fast the line changes over the course of the graph. So slope is the constant rate of change of a line. So when we're talking about slope, there's a few different ways that we can talk about slope and find it. So one way is with our slope formula. So the general formula when we're finding the slope of a line is to take y2, so the second y value minus y1, and divide that by x2 minus x1. So the coordinates of x1 and y1 are 1 point on the graph of the line, and the coordinates of x2 and y2 are another point on that same line or that same linear equation. So that's one way we can talk about it in terms of the coordinates on the graph. The second way to talk about it is to talk about the changes that are happening, so that rate of change of a line. So another way to think about it is the vertical change. So how far the line is going up or down between 2 points, and dividing that by the horizontal change. So we've got our vertical change divided by our horizontal change, which is represented the same way in that y2 minus y1 over x2 minus x1 formula. So the y-axis is obviously going up and down, x-axis is going side to side, so that's your vertical and horizontal change. A shortened way of thinking about that we kind of talk about is called rise over run. So a little less lengthy on that one. But we're just talking about how far it goes up and down divided by how far the line goes over. So with that in mind, let's talk about how we're going to use that slope now. So when we're finding slope, we have to be able to do it from a variety of representations of our linear equations. So the first way to find slope is from a graph. So if we're given the graph of a linear equation, it looks like a straight line, and we want to be able to find the slope or the rate of change of that line. So you can see the steps here. We want to start by picking any 2 points. So you can see on our graph here that we have some points highlighted. We've got one there and one here highlighted in green. So those are our 2 points that we've selected. You can pick any 2 points. We generally want to pick 2 points that have nice coordinates, not decimals or fractions that we can't tell from the graph. So we've selected our 2 points here. And then we want to start at the furthest point to the left on the graph. So that would be our higher point there. We want to find the vertical change going up for positive change and down for negative change, and then move horizontally left or right to get to that next point. So for this one, we have to go down and over so that we can see the vertical and horizontal change there. So in this graph, from the furthest left point, we had to go down 5. So I'm going to write that as -5 and over 6. So we just count off how many squares we had to move. So down 5 over 6. So when I write my slope, we use the letter m to represent our slope. So we'd say slope, or m, equals -5, always our vertical change on top, divided by 6. So to find the slope on the graph, we find that change vertically, change horizontally, and write it as a fraction. Okay? Next, we need to be able to find our slope between 2 points. So not on the graph, but just given to us in coordinate pairs instead. So we're going to use that slope formula that we wrote down up above. So that slope formula, again, just so we have it here to reference, is y2 minus y1 divided by x2 minus x1. So when I'm looking at these 2 coordinate pairs that I'm given, we're going to say that y2 is going to be our second y value that we're given. So that would be that guy right there, the 6. So I am going to say that y2 is 6. And then y1 would obviously be our other y coordinate. So that would be the 0. So in my formula, I'd have 6 minus 0, y2 minus y1. And then I'm going to divide that. And obviously, if we want x2, that's going to be our second x coordinate. So in that same coordinate pair, that's going to be a 0. And then minus our first x value, which is that -8. So minus -8. Be careful with your signs there. The formula is a minus, so you want to include both the minus and the -8. So then we would reduce that. We would get 6 minus 0 is 6. 0 minus -8 would be +8. And then if possible, we always want to reduce our slopes to their lowest terms. So 6 and 8 are both divisible by 2. So I would get a slope of 3/4 as my final answer there. So same idea on this second example here. We want to take our second y value, and then we're going to subtract from that our first y value. So in this case, that would look like -1 minus 2 on the top of our fraction. And then our horizontal change on the bottom between the x's. So that would be x2 would be 8, and x1 would be -1. So when I write that in my formula, it would be 8 minus -1. So again, simplifying that, -1 minus 2 is -3 on the top. On the bottom, 8 minus -1 would be +9. And then I want to check to see if I can reduce, which this one can. They're both divisible by 3. So -3 divided by 3 is -1, and 9 divided by 3 is 3. So my reduced slope there would be -1/3. So when we have 2 points that we're given in coordinate pair form, we want to use that formula in order to find the slope. Finally, let's just talk about the different types of slope you might come across. So you can see in those 2 examples we did above, we got a +3/4 slope and a -1/3 slope. So we have different kinds of slope, positives, negatives, and then a couple other situations. So a positive slope means that the slope is rising from left to right. So it would be some sort of linear function that rises from left to right. Okay, so that's a positive slope. Let's label that. So a positive slope rises from left to right. A negative slope would be the opposite of that. So it would be falling from left to right or going downward from left to right. That's a negative slope. Those are the 2 most common types of slope, but we do have a couple special scenarios that we might come across. One of those is the number that's not positive or negative. We could end up with a 0 slope. When we have a 0 slope, we want to remember that that slope would have to have a 0 in the numerator divided by any number would result in a 0 as our total slope. 0 divided by anything is always equal to 0. So if we end up with a 0 slope, that means there is no slope, there is no rate of change, it's a flat line. So it would be going straight across from left to right. So that is a flat line. And then finally, the fourth type of slope that we might run across is what we call an undefined slope. You may be able to figure out based on the 3 that we've drawn so far what the fourth one might look like. An undefined slope is where we end up with a slope where we get a number in the numerator, but it's divided by 0, and we hopefully know that we can't divide by 0. That's undefined. So when we have an undefined slope, that means that the horizontal change is 0. It's not moving left to right at all. So that would be a straight up and down line. So those are the 4 types of slope we may come across in our variety of ways of finding slope up above. So we're going to use that information to now talk about writing linear equations in a variety of forms. Let's take a look here at the different types of linear equations that you can write. You can see the three forms that we're going to talk about here: standard form, slope-intercept form, and point-slope form. In standard form is the one form where both variables, x and y, are on the same side of the equation. So standard form looks like ax plus by equals c. So a, b, and c are constants of some sort, and then x and y are our variables. So in standard form, we most commonly use it to find the x and y intercepts. The variables being together on the same side of the equation allows us to quickly and easily find the x and y intercepts when needed, because we know when we're finding an x-intercept, the y value is 0, so that y term would drop out. And if I'm finding the y-intercept, the x would be 0, so that x term would drop out, and it makes it relatively easy to find the x and y intercepts. So standard form is the one form where x and y are together on the same side of the equation, makes it easy to find the x and y intercepts. The second form that we're going to talk about is slope-intercept form. This is probably the most commonly used form, especially when it comes to graphing. It makes it very easy to graph a line from this form. So slope-intercept form is y equals mx plus b. And we hopefully remember from the front that m here stands for our slope. So in the equation, we can directly tell that rate of change and how fast or slow that line is changing. And then b, whatever the b value is, that's your y-intercept. So when we're graphing, it makes it easy to start at the y-intercept and then use the slope to be able to move to new points on the line from that original y-intercept point. So that is slope-intercept form, y equals mx plus b. We can easily tell the name because it's giving us our slope and our y-intercept in the equation. The final form we're going to talk about today is point-slope form. So point-slope form is a little longer. It looks like this: y minus y1 equals m times the quantity x minus x1. So that's point-slope form, a little bit longer than the other forms. There's two things going on here, just like the name says. We're given a point and we're given the slope in this equation. So just like slope-intercept form above, this m represents our slope. And then that kind of interesting looking x1 and y1, those are the coordinates of one point, any given point on the line. So x1 and y1 equal a point on the line. In the form before this, in slope-intercept form, it is always giving us the y-intercept. That's the only point on the graph in slope-intercept form that you're going to get is the y-intercept. In point-slope form, we can give you any point on the line, any coordinate pair, and then from there you can use the slope to find the rest of the line. So just a little more variation in that one. So that is point-slope form. So there you can see the three forms that we're going to be using to do a couple things. So we're going to start by converting between the different forms. So if we're given one form, can we change it to another form to be able to do different things with it? And then we're going to graph each form. So let's start by converting between the forms. Okay, so we're starting here with an equation, negative 2x plus 3y equals 15. That is in standard form right now. We are going to go ahead and convert that into slope-intercept form because that's what the directions say to do. So we are given an equation in standard form. We are converting it into slope-intercept form. So we are trying to get it into y equals mx plus b. I want to get the y variable alone. So to do that in this equation, I'm going to start by moving the x term. So I'm going to add 2x to both sides of the equation so that I move that x term away. I'm going to go ahead and write it as 2x plus 15 because when we write slope-intercept form, we generally write the slope first and the y-intercept second. So I'm going to go ahead and write it in that order. It would not be wrong to have it in the other order there. And then the last thing to do to isolate that y variable is to get rid of this 3. So I'm going to divide everything by 3. Remember, when dividing, you have to move. We have to divide every term by the number that we need to get rid of. So I'm left with y over here. 2 divided by 3, we're going to just leave it as a fraction. Our slope is 2/3, meaning we rise 2, run 3. With the x, and then 15 divided by 3 is 5. So 2/3 x plus 5 is in slope-intercept form. That would be my final answer there. All right, the next one that we are doing says to take y minus 4 equals 1/5 times the quantity x plus 7 and convert it into standard form. So right now it's in point slope form. We need to convert it to standard form. So we need to move the x and y together. We also need to get rid of that set of parentheses around the x plus 7 to kind of isolate things. So first thing I would do here is get rid of the 1/5 in order to move it away from everything else. So to do that, I am going to start by multiplying both sides of the equation by the reciprocal of 1/5, which is 5. So I am going to multiply that 5 on both sides, being careful that when I multiply it on the left side of the equation, I have to multiply it by y and the minus 4. So when I do that, I have 5y minus 20. And then that 1/5 and 5 reduces to 1, so I can cross those out, and I'm left with just the x plus 7 on that right-hand side. So now I have two goals to get it into standard form. I want to get the x and y together on one side, and then I want to get the constant by itself on the other side. So I'm going to do that here in one step. I'm going to move the x by subtracting it from both sides over here, and I'm going to move that minus 20 by adding 20 over to the right-hand side. So when I do that, I end up with negative x plus 5y equals, and then on the right-hand side, I'm left with 27. So we can leave it like that. It is also possible in general standard form, we often want that x term to be positive. So another way to write it is to go ahead and multiply everything by -1 so that we get that x term to be positive. So if I multiply everything by -1, I would get positive x minus 5y equals negative 27. So that's another way to write it in standard form with a positive x term. And then finally, example 3 here wants us to take another equation from point slope form, but this time write it into slope intercept form. So again, when we want to get into slope intercept form, we would like to get that y variable alone. So to do that, I'm going to start by distributing the 3 on this one into my quantity x minus 4. So I would get y plus 2 equals 3x minus 12. And then I need to isolate that y again. So I'm going to subtract 2 over to the right-hand side so that I get y equals 3x minus 14. Once that y is isolated and I've got mx plus b on the other side, I am in slope-intercept form. And then we can use those things to help us start graphing. So we've converted some things, and now we're going to start graphing from each form. So when we are graphing each form, we're going to do it a little bit differently depending on the form we're given. So we talked about this first example is in standard form. We talked up above about how standard form allows us to find the x and y intercept easily. So we are going to do that here. We're going to start by finding the x-intercept. So when we find the x-intercept, we know that any point along the x-axis is going to have a y-coordinate of 0. So I'm going to take my standard form and I am going to plug in a 0 for the y-coordinate. So it would look like that. When I simplify that, the minus 4 0 would just be, or minus 4 times 0 would just be 0. So I'm not going to write that. I'm going to write 3x equals 12. And then finally, to find the x-coordinate, I would divide by 3 on both sides and find that the x-intercept is at positive 4. So on my x-axis, I'm going to go over to 1, 2, 3, 4 and put my x-intercept there. And then I'm going to do the exact same thing for the y-coordinate now. So to find a y-intercept, I'm going to plug in a 0 for x, because we know that everything along the y-axis has an x value of 0. So I'm going to plug in that 0. We know that 3 times 0 is 0, so I'm not going to write that. I'm going to get negative 4y equals 12. And then I'm going to divide everything by negative 4 in order to isolate that y. So the y-intercept is at negative 3. So on my y, I'm going to go down to negative 3 and put a point. And then I'm going to use those two coordinates that I've now found to make my linear function. So in standard form, we find the x-intercept, we find the y-intercept, we plot those and use them to make the graph of the linear equation. Our next example here is already in slope-intercept form, which we talked a little bit about up above. That tends to be the easiest one to graph from. You, if you remember correctly, are given in the equation your slope and your y-intercept. So our slope in this equation is negative 1/2. Means it rises negative 1, runs 2. And then our y-intercept is that b value, which is 1. Or if you want to think about it in terms of coordinates, that would be the point 0, 1. So on my graph, I always plot the y-intercept first. So I'm going to go up to positive 1 and plot a point. And then I am going to use my slope to find the next point. So I'm going to rise negative 1, which means I'm going to go down 1 over 2 and put a point. From that point, I'm going to do the same thing. Down 1 over 2. That allows me to make points. Now, if I run out of graph or I need to plot more points the other direction, you can switch and rise 1, run negative 2. So you can flip where the negative is. Rise 1, run negative 2. And you'll see that those make a linear function. So that is slope-intercept form. Lastly, we are going to graph an equation in point-slope form. So if you remember from up above, we are given the slope, which is that 2/3 in this case, and then we are given another point on the graph. And in this case, remember that's our x1 and our y1. So our x1 in this case is 1 because it comes from our equation here. And then our y1, or our y value of our coordinate, would be negative 2, because if you remember from our formula, the formula is y minus y1. So this up here is really y minus negative 2 to make that positive. So that's why y1 is negative 2. So I'm going to do a very similar thing to what I did on example 5 with slope-intercept form, but now I'm going to start at the point 1, negative 2 instead. So I'm going to go over 1, down 2, and plot that point. And then I'm going to use my slope, rise 2, run 3, both positive, so up 2, right 3, to plot my next point. And again, remember, if we run out of room, we can't do any more points, you can also flip that and go down to left 3, because a negative and a negative would also make a positive 2/3. So we have enough there to make a nice line. Oops. And now we have graphed our point slope equation. So you now have your 3 forms of linear equations, and you hopefully understand a little bit more about slope. Thank you.